So basically, a lot of this trig stuff was discovered using similar triangles. So let me explain exactly what that means. All right, so I'm going to draw a right triangle. And then what I want you to think about is this, that this is some angle over here. All right, and we're just going to call it X. Now, if I were to draw a parallel line, well, and understand this is a right triangle. So if I were to draw a parallel line, let's say here, what's true about, let's call this A, B, C, and then let's call this X, Y, and Z. All right, first of all, what's true about the triangles? They are most definitely similar by angle similarity. So then what do you think is true about A over B and X over Y? Yeah, they're definitely proportional, right? And then of course, what could we say about C over Z and if we said B over Y? They're definitely proportional, correct? Now, does it matter really what I draw here? As long as it's parallel, what's true about all the sides? Yeah, so what they figured, which I thought was super amazing and super impressive, is that if I know, believe it or not, this ratio, A over B, or if I know X over Y, what's true about this angle? Did it change? No. Actually, if I know this and I know this length, believe it or not, I will then be able to determine what? The angle. That was the mystery. All right. So believe it or not, when I was in high school, they invented calculators, believe it or not. And that was like the big deal, was getting a calculator, because we no longer had to look at the tables, right? So a long time ago, what they did was they measured the angle, and then they measured the ratio of A over B, or they measured the ratio of A and C or B and C. And if they could tell me that ratio, then they could figure out what? They could figure out the angle. All right. So they knew once they had the ratio, they could determine the angle. Now, of course, how powerful is that? The reason why that was so powerful, believe it or not, was if they knew the angle and they could calculate the distance from a wall, they then could determine how high or how tall the wall actually was. All right. Now, believe it or not, that was pretty important. And why do you think that's important? Because during war, believe it or not, that's how they were able to calculate the heights of different buildings. And so then they were able to use their projectiles to hit right on the mark. All right. Which created a mystery because they didn't understand that relationship. So all of this, I believe, was discovered by mathematicians that helped people in war, actually. All right, super fascinating stuff. So again, it was all calculated by hand. All right, but he was smart enough to realize that if he were able to calculate the angle and he knew one of the distances, he could calculate any other distance. All right, so why are these ratios given all these names? Because that's going to help you solve all of the triangles. So now let's take a look at exactly what is going on here. Or when we draw our right triangle, All right, we're going to call this x. All right, now in relation to x, this side is called the opposite side. Now, opposite of what? Opposite the angle. Opposite the angle. All right, for whatever reason, they decided to call this the adjacent. All right, that's called the adjacent. And obviously, this is called the what? That's called the hypotenuse. All right. So then we're discussing the ratios, and that's an important concept. When they're discussing the ratios, they made up these definitions. All right. And again, I have no idea why they came up with these words, but sine, not sin, that's sine. All right. It's the sine of x is equal to opposite over adjacent. All right. So the sine of x is the ratio of the opposite side to the adjacent. Then we have something called cosine of x. And cosine of x is I already made a mistake. Opposite over hypotenuse. I was a little bit ahead of myself. Sorry, guys. Sine of x is opposite over hypotenuse. Go back, fix that. Sine of x is opposite over hypotenuse. Cosine of x is defined as the adjacent over the hypotenuse. And then tangent of x is defined as opposite over adjacent. All right, opposite over adjacent. All right, now, again, when you get into high school, you'll add 3 new trig functions. You will learn that, and you might as well just write it down right now, that the cosecant of x is the hypotenuse over the opposite. And those are just what? Reciprocals is what they're called. Secant x is referred to as the hypotenuse over the adjacent, and cotangent of x is the adjacent over the opposite. Now, if you'll notice, they chose these to put on the calculator. Is it necessary to put these on the calculator? No, because they're just reciprocals, right? So if you know sine, you're going to know what? Cosecant. If you know cosine, you know secant, you know tangent, you can figure out what cotangent is because they are just reciprocals. Now, keep in mind, these are simply what? Ratios. They're just ratios. All right, so this over here, all right, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, that's the key to success. All right, so then some people came along, and when I was in high school, they just said SOHCAHTOA, all right, and they called it SOHCAHTOA, all right, and then my math teacher said it was some famous Indian who discovered all this SOHCAHTOA, all right, but of course, that's definitely not true, all right. So that's just some way to help you try to remember the rates or the ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. If you go to the public schools, all right, they will tell you, they like to remember it as some old hippie caught another hippie tripping on acid. That's what they'll tell you. All right. So I haven't heard that from the from the private schools, but from the public schools, some old hippie caught another hippie tripping on acid is what they like to say. All right. I prefer SOHCAHTOA, the famous Indian chief. All right. But you decide how you want to memorize that. All right. Yes, that is it. All right. Very good. I had a feeling you would remember that. All right. Now, with that being said, There is just a tremendous amount of information today and tomorrow. I think today I decided to use the odds, go through the odds with you, and then tomorrow I'm just going to go through the evens. I just feel like there's too much information in one section. All right, now again, as I tell everyone, this section is pretty easy if you understand the ratios. All right, the trig functions are simply ratios. All right, that's all they are. And you will discover the power of the ratios, all right, in this lesson. All right, if you know the angle, all you need is one side and you can figure out the rest. All right, so again, let's see how we're doing. All right, so let's go to question number 1. Well, actually, we will do question 1, 2, 3, 4, 5, and 6. All right, now, the first thing, which I want to get rid of, is all this extra stuff that bothers me. Okay, so now, here's something else I want to try to help you with. I don't understand why the book does this, probably because I don't know why. I would never do this. All right, does everybody understand the 12, 20, 16 has a common what? 4. And what happens if you make a ratio and there's a common 4? You're just going to simplify it, right? So in my opinion, we should just go ahead and divide by 4, and that makes that a what? 3, 4, 5, right triangle. Makes it a 3, 4, 5 right triangle. All right, now you're going to learn something super important right now. All right, we're going to talk about A, sine of A. So everybody has to look at this, sine of A. All right, now, which one is considered the opposite side? What number? Yeah, CB, that's correct. Now, it's kind of interesting, somebody said that so fast, A, all right? The opposite side has the other 2 letters, all right? I never really had to think of it like that because I'm just saying, well, the opposite is directly opposite, all right? So again, some people get confused. I'm not sure exactly why. All right. So opposite of angle A, and then AB is called the adjacent, and AC is the hypotenuse. All right. Now, why am I making that clear? Because look, what's the opposite of C? Is it the same as A? No, that's what causes the problem. All right. You always want to take a look at what angle you're referring to determine what's the opposite. Now, can we ever discuss the tangent of B? And the answer would be what? No, because the hypotenuse is the same as the what? Opposite. All right. So we never can really say the trig function with relationship to the right angle. The only perspective we're looking from is either from C or from A. From C or from A. All right. So now, express each ratio as a fraction. Do I care about decimals in math? No, decimals should not be allowed. All right. So all we're doing is we're writing the fraction. All right. So if I'm asking for the sine of A, the sine of A, remember, is the opposite over the hypotenuse. So that would be what? 4 over 5. All right. So now let's take a look at tangent of C. What's the tangent of C? Remember, tangent is opposite over adjacent. So tangent of C is what? 3 over 4. All right. I expect you to mess it up a few times. All right. Think about it clearly. Cosine of A, 3 over 5. And now tangent of A, 4/3. And then cosine of C, 4 over 5. And then sine of C, 3 over 5. Beautiful. All right, so now I'm going to show you the power of your calculator. All right, so now if I know that the sine of A is equal to 4/5, All right, the first thing I want to do is on your calculator, everybody has to hit the mode button. And mode, you want to be in degree mode. All right, there is a radian mode also. Radian is for when you get into pre-calculus. We'll teach you about that. But right now, if you don't have your mode in degree, you'll get all the problems wrong. All right, all the problems will be wrong if you don't. All right, so everybody hit mode, make sure you're in degree. All right. Mode, M-O-D-E, hit that button. And then you highlight it. Come on, guys. You guys all know how to handle technology, right? Hit the mode, and then look where it says degrees and radians, and you want it in degrees. And you highlight it on degree, hit enter, and then you can quit. And now you're in good shape. All right? So now, here's what I want. All right? First and foremost, guys. All right? I want to make sure everybody understands that this is the measure of an angle. That's what we're trying to find. We're trying to calculate the measure of this angle. All right, so I need everybody to understand I'm trying to get at A, right? So what is in the way? That's correct. The sine is in the way. All right, so I want to eliminate the sine. Just like if there was addition, we would do what? Subtraction, multiplication, division, squares, square root, square. They're inverse functions. So what do you think the inverse of sine is? Very good. Inverse sine. All right, inverse sine. Notice, look on your calculator where it says sine. Right above it is the what? Inverse sine. What do you think those buttons do to each other? They cancel each other out. So now watch what I want to show you. So I'm going to do the inverse sine of this side of the equation. And now I'm going to do what? The inverse on this side of the equation. So what happens to the sine and the inverse sine? They cancel each other out. So now we say A is equal to the inverse sine of 4/5. So everybody do inverse sine of 4/5. How much is that? 53.13 degrees. All right, we'll just say that. All right, so if I were to measure this angle right here, it would say it's what? 53.13 degrees. So we just were able to calculate the measure of an angle based solely on what? The sides. All right, that's how powerful it is. All right. Now what I want to do is I'm going to try number 4. All right, so I'm going to write tangent of A, and don't just listen to me now. Tangent of A is equal to 4/3. So how do you think I want to get to A? What am I going to hit? Now I'm going to do inverse tangent, and I want everybody to practice writing this out, inverse tangent. So A is equal to, don't spoil my surprise, the inverse tangent of 4/3. Why is it the same? Because it's the same what? It's the same exact angle. That's what I'm trying to tell you. It doesn't matter what two sides you know. If you know two sides, you can figure out what the angle is. All right, and now I'm going to look at the last one over here with A in it, and that's the cosine of A. So I'm going to write down cosine of A, we said was equal to what? 3/5. So I still am trying to get to A, right? So how do I undo a cosine? Inverse cosine. You say inverse cosine. What happens to the inverse cosine and the cosine? They cancel each other out. So A is equal to the inverse cosine of 3/5, which is what? 53.13, which I'm trying to impress upon you is what? Same exact answer. Every single time I'll say, find this angle. And they say, well, what if I do tangent? Somebody says, well, what if I do sine? And somebody says, well, what if I do cosine? Do I really care? No, it's all going to give you the same answer. It's all going to give you the same answer. If you set up the proper proportion, it will give you the same answer. Yes.
Why did they have all?
What?
Why did they have like all?
Well, that's a pretty good question, because occasionally you are going to know a single part and an angle. You may not know two sides. Does that make sense? So what we're going to end up doing is we're going to end up looking at we'll end up looking at a triangle. We'll say, okay, I know I measured this and I said this was 31 degrees. And I know I'm what? I'm 50 meters from the wall. All right, I'm trying to get a projectile up on the top. Right, so I know what that distance is. All right, does that make sense? Right, so there's lots of reasons. All right, they gave all three of these, so if one side or one angle was missing, you could calculate the other side. All right, so now what we're going to do is, if angle A is 53.13 degrees, somebody tell me what C is going to be. What is it? 36.87. You are brilliant. How did I know that? Yeah, these two angles, angle C and A, are complementary. So once we find the measure of one, we should be able to find the measure of the second angle, all right, that is unknown. But of course, we're not going to do that. We are going to find, for example, number 6, sine C is 3/5. So how do I solve for C? We do C equals inverse sine of 3/5. And somebody hit inverse sine of 3/5, and that should be what? It should be 36.87. All right. So again, now we'll do inverse cosine of 4/5, just for practice. Inverse cosine of 4/5. And it should be the same answer. And again, trust me, you should do it. All right, you should do it, because you're trying to get the recognition of what exactly is taking place. And I'm trying to show you, if you're looking for an angle, it doesn't matter, all right, what function you use. You're always going to get the same one. And finally, inverse tangent of 3/4. So C is equal to the inverse tangent of 3/4. And you should be able to tell me same exact answer. Same exact answer. All right. So again, with that little bit of information, that is really super powerful. All right. And those of you guys who are good at this, all right, your SAT score probably just increased by 50 points. All right, because that's about how many points are on the test. All right. If you understand trig, you'll be much better on the SAT now. All right. So again, that's just the beginning. All right, now what I want to do is I want to look at number 7. It says, use a special right triangle to express sine of 60 as a fraction. And do I care about a decimal? No. All right, so what I want everybody to do for number 7 is we're going to draw a 30, 60, 90 right triangle. And this is my 30. And this is my 60, correct? This is my 90. What did I say the hypotenuse was yesterday? What number? What variable? X, thank you. What's opposite 30? X over 2. What's opposite 60? X over 2 radical 3. All right? That's something you should know. So now they're asking you to express the sine of 60 degrees. So here's 60 degrees. How do we define sine again? Yes, sine again is opposite over hypotenuse. So we're going to come right over here and I'm going to write sine of 60 degrees is equal to, what is that equal to? X radical 3 over 2 divided by what? Thank you, sir. That is true. What happens to the two x's? They cancel. So the sine of 60 degrees is equal to square root of 3 over 2. Now, square root of 3 is about 1.71. If I divide that by 2, it should be like 0.86. So now everybody do sine of 60 degrees on their calculator. And I think it's like 0.867. Is that right? 8.66? Yeah. Thank you. All right. Now, how did I know that? Just because square root of 3 is 1.71. All right. So again, that's what they're talking about. All right. When you get to advanced math, we are not going to say 0.866. We are going to say what? Square root of 3 over 2. All right. Square root of 3 over 2. That's really super duper important. All right. Small right now, but in the future, you'll do it thousands of times. What? I don't know what you mean you didn't get that. Did you do sine of 60 on your calculator? What? All right, that's, again, I'm really glad you asked. All right, so everybody has to be good at fractions. And Harris is the only one who was able to say, I'm not sure. All right, I hope everyone will ask me a question. All right, because again, understanding fractions is really important. So this is what I have. Do you agree with that? Dividing by x is multiplying by the reciprocal. Do you agree with that? Or do you want me to go back a step again? You understand that? And so now what can I do with the x's? One's on the top, one's on the bottom. So they cross out. Do you agree with that? Yes? You sure? All right. Again, good, go.
What button do you have to get sine 50? Like for sine, they want me to do sine 50.
Let me see your calculator. No. Just don't hold it up.
Oh,
Yeah. Yeah, you can. I don't know. Hit clear. Hit clear. You clear? Hit the sine button. Then 60.
Oh, okay.
Right. A lot of times on the old calculators, you'd have to hit 60 and then you'd have to hit the sine. But on these, you literally type in the sine first, right? And if you want to find the angle, listen, whenever you want to find the angle, you're doing inverse sine, inverse cosine, inverse tangent. All right, so I'm pretty happy with that. All right, so that's a really, really good start to trig. All right, really good start. All right, now what I want to do is I'm going to show you the power of your calculator now. All right, because these are the conditions that I think Bo was talking about. Why do we need all of them? All right, the reason we need all of them is because we're not always going to know. All right, we're always going to have different types of triangles. So in this case right here, please watch and listen because this is the important part. All right, I'll probably just do 8, 9, and 10. All right, so now I always tell my kids you should circle the 3 things or the 2 things that you know and the 1 thing that you don't know. All right. So with that in mind, what trig function is involved here? We have the angle. What is x called? With respect to 52. And what is 13? So now you say, okay, what trig function involves the opposite and the adjacent? Tangents, right? That's how simple it is. But listen now, you got to pay attention on me on this one now. This is showing you how to use the trig now to solve problems. All right, so once again, I knew 52. Could I figure out the other one was 38 and use 38? Yeah, if you want to do that, that's okay, but it's not necessary. Use the 52, the x, and the 13. What? Hold on. So now we're going to write it. That is true. So we write the trig function, tangent. After every trig function comes an angle. 52 degrees equals, what is the opposite? What is the adjacent? There you have it. That's what should be written down. Tangent of 52 is equal to x over 13. Now I'm solving for x. So I'm just going to write x is equal to 13 tangent 52. Now, I want to show you something because everybody asks me this and they tell me, oh, they got the different answer. You got a different answer because you didn't listen to me. I want everybody to hit the tangent button first and then do 52. Now, do you understand it open the parentheses, correct? So do we want the tangent of 52 times 13 or do we want the tangent of 52 and then find that and then multiply by 13? Right? So if you do this, if you do tangent of 52 times 13 and you don't close the parentheses, it's going to multiply 52 times 13 and then take the tangent. All right, that's why I recommend that you should just put the 13 what? In front, then you don't have to close the parentheses. All right, so do 13 tangent 52 or tangent 52 close parentheses times 13. So now it says round to the nearest hundredth. 16, but in real math, we always round to 3 decimal places. I don't care what they say. All right, rounding to 3 decimal places. So 16 point what? 16 point, you said 639? All right, 16.639. That is the correct answer. All right. So again, I always write the constant before the trig function, not after. That saves yourself a step. All right, so let's check out number 9. Let's see how we're doing. For number 9, again, I like to circle the 24, the x, and the 61. What is the relationship 24 is to 61? That's the opposite. And what is x in relationship to 61? That's the hypotenuse. So what trig function? Yes. All right. So we say sine of what? 61 is equal to 24 over x. Now, because we are mental giants and we're not mental midgets, all right, we don't have to cross multiply. Everybody in here should be able to just look at that and say, well, obviously, x is equal to 24 divided by the sine of 61. And every year, people blow it. All right. Now, if for some strange reason you can't do the math, you just make it this sine of 61 over 1, and then you cross multiply and divide. All right. That's if you're a mental what? Midget. All right. The mental midget does it that way. The mental giant just says, well, I just know it's 24 divided by sine of 61. If you're not sure, remember, it's just 24 times 1. Then you divide it by sine of 61. That's what you're doing in your head. All right. Anybody have any questions with that? So now, someone please tell me 24 divided by the sine of 61. 27.44 what?
0.
All right. 27.44. I'm happy with that. All right, so let's knock out 10 here. Okay, so I'm assuming we did a what? Tangent, we did a sine, so this is probably what? Cosine, but I'm not 100% sure. So I'm looking here, I'm looking here, I'm looking here. And hypotenuse and adjacent are involved, so we're going to do cosine of what is equal to, what is it? All right, so because we are brilliant, x equals 19 cosine 27, and we round to 3 decimal places. 92 what? Thank you, 16.929. Right now, honestly, I just think that's super duper easy. All right, but you have to know the ratios. You have to know the definition of the trig functions. Yes, sir.
When you get to cosine 27, and you go to x over 19, can't you just calculate cosine 27?
Brilliant. That's exactly what I said. What did you think I said? All right, go.
Well, when the x is on, when the x is in the numerator, do you not do the cross multiply?
No, you can. I don't care, right? But I'm just knowing I have to get rid of the 19. So I just multiply by 19. That's what I'm trying to make sure everyone understands that. I don't want you doing the cross multiplying, right? You're supposed to be good math. Good math means I'm trying to solve for x. So I just eliminate the divided by 19 by multiplying by 19. If you need to, every single time you can make it over 1. And some kids are just much more comfortable just making it a proportion, cross multiply, divide. All right, but you don't have to do that. All right, yes, sir. All right, so let's look at this now. All right, so let's do 11. All right, so David is building a bike ramp. He wants an angle that the ramp makes to the ground to be 20 degrees. If the board he wants to use is 3.5 feet long, how tall will the ramp need to be at the highest point? All right, and again, believe it or not, these are actual things that take place. All right, you know the angle, you know the length of the board, so we want to know how high do I have to make it? All right. So what trig function? Sine of what? 20 is equal to x over 3.5. Thank you. So now x is equal to 3.5 times the sine of 20. Now here we can say 1 point what? 197 what? Yeah, feet, because they have units. All right, so if you want to make a ramp that's 20 degrees, then the height or the hypotenuse is 3.5 feet. The height, you just make a board that's about 1.197 feet and you will satisfy those conditions. All right, any issues with that? Okay, now we'll just continue. All right, number 12. All right, number 12. I need to figure out the angle now. All right, so what did I tell you about when you need an angle, we're going to have to use what? Inverse, right? So what's the relationship between 5 and 9 now? Opposite and hypotenuse, so we're going to use what? You're going to write, everyone's going to write down sine of what angle? Z is equal to 5 over 9. And just because we're great and I'm trying to establish that you understand something, you're going to write down Z is equal to what? No, Z is equal to inverse sine of 5/9. Do me a favor, guys. I can't tell you how important that is. All right, right now, I know you think you know it, whatever. All right, but you're not. In a couple weeks, you'll forget things. That's why I'm asking you to write it down. Make sure you understand. When you're using inverse, that means you're finding a what? Angle. When you're using sine, cosine, tangent, you're finding a length. All right, to find an angle, you do inverse sine, inverse cosine, inverse tangent. So now we know Z is approximately what? 7 what? 4.9 degrees. All right, so let's knock out 13. We're still looking for Z. All right. So someone tell me what I'm using. What is it? Adjacent hypotenuse referring to cosine, not cos or sin, cosine, cosine. So right now we're going to do cosine of Z is equal to what? 10 over 14. So Z is equal to what? Inverse cosine of, well, yeah, 5 over 7. Does it matter if we use 10 over 14 or 5 over 7? No. Z is approximately how many degrees? All right, I like it. All right, let's knock out 14. So I'm looking for Z. So what am I doing? Sine of Z equals what? 15 over, yes, I'm happy with those guys who are reducing the fraction. But does it really matter? No. So Z equals inverse sine of 3/5. So Z is approximately 36 point what? 87. All right, I'm happy. All right. I just don't think it's that hard. All right. Do not think it's that hard. All right, here we go. Now we're on number 15. Solve the right triangle. What do you think that means? Find all the missing pieces. Find all the missing pieces. That's what that means. So I want someone, now come on, we're really practicing here. All right, we're going to try to use the information that I taught you about how to find RS. All right, so we're going to find RS. All right, we're going to find RS by doing what? Yes, by doing the Pythagorean Theorem, but because we're brilliant, what is common? 3. Please practice. It's good mental exercise. You're going to go to high school next year and you're going to say what that answer is. People are going to look at you like you are weird. And they're weird because they don't know. All right, there's a common 3. So everybody puts down a 3. Now in your brain, that means this side over here is actually a what? 2. And this over here is a what? 3. So now you mean to tell me you can't do 3 squared minus 2 squared in your head? 3 radical 5. That is the answer. All right, everybody should be able to do that. All right, that's why in class you are practicing. All right, anybody have any issues with that? I'm agreeing. All right, now I need the angle. Now don't argue with me. Does it matter what trig function you use? No. You have to pick one. Now I'm going to pick one and you're going to pick a different one. You're going to say, well, I use sine or I use tangent. Does it matter? It doesn't matter. So let's not argue about it. I want to figure out what angle R is. How did you do that? Hold up, Davis, go. Shh. Well, I know you're brilliant, all right, but I want to know, all right? I want to know what trig function, sine of what? R equals 6 over 9. Brilliant. So now we say R is equal to, which is? Is that to 3 decimal places? But it could be 0. All right, I'm happy with that. And then put the degree sign. All right, now, do I have to do trig function to find T? No, because we're brilliant. We know that T is the complement of R. So T is equal to what? 48.19 degrees. Now, can you do the trig function to see if that's correct? Yes, but, you know, that's how you can kind of check your work. All right, does anybody have any questions now? That's what it means to solve a right triangle. Find all the missing parts. All right, find all the missing parts. Anybody have any issues with that? Any issues? Okay, so here we go. Man, there's a lot of work here, guys. All right, so here we go. Let me just to make sure. All right, tonight, 17, 19, 21, 23, 25, 27, and 29. That's good. All right. Now, look at the special right triangles. All right. I did an example like that. So I want you to try to set those up. All right. I want everybody to try to set those up. All right. Use the information on the special right triangles. All right. What we did. All right. Just as a review, if you forgot, write this down. This is 30, 60, 90. This is x over 2, x radical 3 over 2. And then if you did a 45, 45, 90, this was x, this was x, this was x radical 2. That's what you're doing. All right. And then you're just using the ratio to reduce the fraction properly. All right. But please, guys, this requires a little bit of work. All right. You know, maybe some of you aren't used to working so hard. All right. You got to get this work done. All right. It's going to be a nightmare on your test if you're not working. All right. There's no way I can explain this in one review. All right. You got to work with me. All right. I think I did post the answers, correct? Yep. The answers are posted. All right. So if you're having issues, you don't know something, I believe they're also the worked out solutions. So you should be able to look at it. It'll explain exactly what is meant. All right. Does anybody have any issues? All right. You got like 7 minutes, guys. All right. No time to mess around. Get the work done now. Spend 7 minutes. Get it done. All right, boys at home. Hopefully you did all right with that. You understood everything that I was saying. Have a fantastic day. I will see you tomorrow.
Thank you. Have a good day.
Bye.
Yes, I'll take care of it now. Just give me 1 second.